This video is going to cover section 3.2, truth tables, equivalent statements, and tautologies. So in this video, essentially what we're doing is we're proving whether something is true or false, and we're going to be using something called a truth table to do that. Okay, so just recall from a previous section, I want to say maybe it was 3.1 or 3, I'm sorry, yeah, 3.1 probably. But this right here, so recall, okay, that a negation is pretty much saying not. So right here, if P, remember P is just a simple statement, okay? If P is true, then not P would be false, okay? And if P is false, then not P would be true. Remember that this part right here, these are all the possible combinations, okay? So these are the possible, I guess you could say truth values, okay, to be more math specific. The possible truth values of P are either true or false. So therefore not P is the opposite, false and true. A conjunction would be the and statement. Remember this is and. And remember that a conjunction is only true if both of them are true. So if P is true and Q is true, then conjunction is true. If P is true and Q is false, then it's false. And notice all the other combinations are not going to work because the only way this one's going to be true is if they're both true, okay? Because and means everything has to be true. And finally, disjunction is the or statement, which means as long as one of them is true, then the statement is true. In other words, in this case, it's going to be kind of the opposite of and. You're going to have three truths and only one false, because in these ones, true is here, and true is here. The only place where it's not going to be true is the last one where you have two F's for false. Okay, so just remember, because all of our truth tables are based on these three things. Okay, so we're going to go ahead and go right into an example. It says construct a truth table for not P or Q. So remember this is or, and I'm sorry, or Q. Okay, and then we want to determine for part B what happens when P is true and Q is false. So what you're going to do to even start this table, okay, is you're going to start with P and all the possible combinations. Make that a little bit straighter. Okay, so, and I'm just going to extend it because I don't know how long this is going to go quite yet. These do take some time, okay? So for P and Q, for sure, I'm going to have those four combinations. So let me make that space here. So I'm going to have when P is true, Q might be true also. When P is true, Q might be false. When P is false, Q might be true. And when P is false, this one might also be false. So remember, these are your standard truth values that you always start with because these kind of help you do everything else, okay? So then let's see what else do we need. So we're going to see what else we need to fill this part out by looking at this up here. So we already have Q by itself. We don't have to do that one again. That one is right here, okay? We don't have this. So to get this, notice that the components are not P and Q. Again, Q we already have, but we need to have not P. So I'm going to go ahead and do not P right here, right next to it. And so we can, oh, let me get the other color. So we can see what the values are for that. Okay, so for not P, you're going to be looking at, well, P, okay, and you're going to negate whatever's in this column. So if P was true on this one, then P would be false here. If P was true here, it's going to be false. It's going to be true, and it's going to be true. So again, you're looking at, to get not P, you look at P and just change all of these ones to the opposite, okay? So there's not P, okay? And now we have to have this entire thing that I circled. So this whole thing right here is going to go right next to it. So I'm going to go ahead and do that next. Let me kind of color code that. So this would be not P or Q. And these do take some practice, guys, okay? A lot of times students don't know where to start, so you kind of have to look at, well, what do I need, okay? So I already have Q, I already have not P, I already have Q on this one again. So I have to have this whole thing together now, okay? Remember that or means that as long as one of them is true, the statement is true. So I'm going to be looking at not P, so this one. Let's use this one. I'm going to be looking here, and I'm going to be looking at Q for this one because those are my two, not P or Q. Remember, this is or. So I'm looking at these two columns, and I'm going to erase this in a bit just so you can see. And what I want is I want as long as one of these is true per row, then this would be true, okay? So let's look at the first two. We have true and false, so therefore it's true because we have at least one true right here. Then we have false, false, so that one's going to be false. True, true, so at least one of them is true. And false, true, at least one of them is true. So this right here represents the inside part of this, okay? Now, there's one more step because this is kind of a longer one. Actually, no, two more steps. My bad, two more. So we have to go ahead and negate this now. You see how there's that little negation? So now here, I'm going to go ahead and do that one. So I'm going to negate all of this. So P, sorry, not P or Q. So it's kind of like a step-by-step process here where you kind of have to work from the way from inside. Oh, what happened there? Oh, that's fine. You have to work your way from the inside out. Okay. So we're going to do that on this one. I'm just going to make that little thing a little bit more clear. So this was not P. So all I'm doing is I'm taking this right here, all of this right here, and putting it into a knot. So that means that all of these values are going to flip. So I'm going to have false, true, false, false. Okay. And finally, because we still have one more. I know, like I said, these take some time. So I'm going to have to extend this a little bit more. Okay, finally we have the entire thing. So the entire statement, oh, that's horrible. So I'm just going to underline the whole thing. So this entire thing is saying that I want all of this or Q. So in other words, I'm going to write the whole thing. So not P or Q or Q. Because I have to, in the end, what you're trying to do is figure out the truth values of the entire statement, okay? But to do that, we have to build it up. So for this one, I'm going to be looking at this column and the column at the way and over here and Q. And I want to see if either one of those is true. So let me get another color here. Let's do this one. So remember that we have this or statement, which means as long as either this or this is true, it's a true statement. So I'm gonna follow my arrow. So I'm finally looking the ultimate thing. That's horrible again. My writing skills are not that great this morning. So this column, and let's see, other arrow goes this column. So as long as one of those is true, this is true. So let's see, we have a true here. So yes. We have a true on this one, so this is also true. We have a true on this right here, so that's also true. But the last one is just false, so that means that we have false for that combination, okay? So these would be, this part right here would be our values, okay? These are the truth values for this particular problem, okay? Now it says for part B, use the truth table from part A to determine the truth value of this whole thing, given that P is true and Q is false. In other words, for this combination, P is true and Q is false. We're going to find that. So let's see, P is true here and here, but they want Q to be false. So we're looking at this row right here for part B. This is for part B. So from this row, it looks like it's true. So for part B, the answer is true. Okay. When you do your homework problems, make sure that you do have to do this table. Okay. If you just put true, false, or you just give me the answers, you will not receive credit. You need to show how you got there. Okay. We're going to go ahead and do another one. just to practice. Okay, this one's a little bit lengthier. I'm going to go a little bit faster. If you need to slow down, just pause the video. Okay, so we always start with P and Q. Okay, and we're going to extend this all the way. I don't know how long it's going to go. All right, so remember that all the possible combinations are the same. I mean, you can change the order, that's fine, but they do have to be essentially the same. So we have to have true, 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 false, um, false, true, and false, false. Okay, so we have to have all those for sure. Now it looks like up here we need several things. We need not Q, so I'm going to go ahead and do not Q right here. And we also need not P, so I'm going to do not P right next to it. So I'm taking it step by step. Okay, so it looks like not Q would be all of these but opposite. So false, true, false, true. Not P, remember this one I'm looking at here. Okay. Not P would be looking at this one right here. So I'm going to change all of these. So false, false, true, true. Okay. Let me erase that 'cause I don't want to have too much writing on this. And then we're going to move on to the next part. See what else I need. So it looks like I need P and not Q. So I need an and here. Remember, that means they both have to be true. And then I also need this statement right here. So I need, let me see, let's color code these. I need all of this, and that's an and I need all of this, and that's an or. So let's do the P and not Q first. So P and not Q will go first. Remember that for and statements, they both have to be true. So the only time this is going to be true is if they're both true. So for this one, I'm looking at right here, P and not Q. So not Q would be these two. So I'm looking at these two columns, okay? So I have true, false. So that's going to be false. True, true. So that one is true because remember, and means they both have to be true. False, false. So that's still false. False, true. So that's false. So it looks like I only have one true on this one. Okay. I'm going to do the one right next to it. So that's this one right here. Not P or Q. And for this one, I'm looking at the other two. So I'm looking at not P, which is this one. Okay. And I'm looking at Q, which is this one right here. Okay. So let's go ahead and do that. And for this one, it's an or statement, which means as long as one of them is true, then it's true. Okay, so let's see. Not P and Q. You got to be careful too. Make sure you don't look at the wrong column. Hopefully, I haven't done that yet. So not P, we have false, true. So we do have a true. So it's true. False, false. So false. True, true. So it's true. And true, false. So it's true. Remember again that this one, they both have to be true for, I'm sorry, at least one has to be true for it to be true. We're going to look at the last one now. So we're going to look at the entire thing now. So I'm looking at this whole thing, and this is an or statement. So I'm going to write this whole thing here. I'm going to try to squish it here. Let's see, P and not Q, or not P or Q. So for this one, I'm looking at this column and this column, okay, because that's the final answer. So again, for this one, it's an or statement, which means we just need to have at least one that's true. So let's see. Yep, there's a true right there. There's a true right there. True and true. So in this one, it turned out that they all came out true, which is kind of nice. There's actually a word for that one we're going to see in a bit, okay? So in this case, part A, this would be our answer right here, okay? For part B, it's asking us to use the table to determine the truth value, given that P is true and Q is false. So let's see, P is true here and here, and Q is false. So I'm looking at this row right here, and we already know that it's true, so we can go ahead and put true. Okay, and that is it for that one. So let's move on. This one I'm just going to kind of show you because I don't want to have to do all this work again. So we have a definition about equivalency. It says two statements are equivalent. So remember, equivalent means that they have the same values in this case, okay? And actually, I'll get to that in a bit. If they both have the same truth value for all possible truth values of their simple statements. So in other words, the parts that I was circling, if those come out the same, then they're equivalent, okay? The notation for equivalent, I forgot to put that here, is three little, kind of like an equal sign, but with an extra little line, okay? So to show that all of this and all of this are equivalent statements. So here are the two truth tables. We're not going to go ahead and do them. They're already done for us. And the thing with these is you do have to have the same pattern here. So notice that for my PQ, okay, they're the exact same as the PQ over here. So true, 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 false, false, true, false, false. Same thing over here. And they didn't show all the work, but essentially when you do all the work, these are your truth values, okay? So these are the truth values, and they're labeled on the bottom too. And then these are the truth values for this one. So using the same, setup that we had here, notice that it's false, false, true, false, 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 true, false. They're the exact same. And that means that these two are equivalent. So therefore, we have this notation down here. Okay? And that's essentially what that is. So we're going to go right into an example. And this one's not too bad. Okay, we're going to go ahead and do this truth table pretty quickly. Let's see. So we're going to start with P, Q. Okay. I'll try to go a little bit faster. I know that these videos can get a bit lengthy sometimes. All right, so the combinations we have are true, 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 false, false, true, false, false. Okay, and it looks like we need, let's see, we need to have a not Q in here. So not Q would be the opposite of Q, so that'd be false. I'm looking right here. I'm looking right there. So false, true, false, true. Okay. And it looks like I also need this whole thing right here. So I'm going to do that one next. So P, P and not Q. Remember that and means they both have to be true. So for this one, I'm looking at here, P and not Q. So let's see, true, false. So no, that's false. True, true. Yes, true. False, false is a false. False, true is true. I'm sorry, false, true is false. Because they both have to be true. Be careful when you do these because like I said, I'm going a little bit fast, so it's really easy to make mistakes. So just if you ever catch me in a mistake, let me know and I'll add some points to one of your homework assignments. Okay. All right. So okay, so after that we need the final one, which is going to be this entire thing. So P or all of that. So P and not Q. So for this one, I'm looking at now P and then all of this. Okay, remember that or means as long as one of them is true, it's true. So we have true, false, so that's true. True, true, that's true. False, false, that's false. False, false, that's false. So this is what we're looking at now. So in other words, these are the answers, okay, for P or all of this. And we're trying to prove that all of this and P are equivalent. So P is over here. Let's see. True, 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 false, 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 false. And we just proved that they are the same. So because they have the same truth values, okay, then we can say that these are equivalent. So I'm just going to note, oh, I'm out of room here. So I'm going to put it up here. So P or P and not Q is equivalent to P. We proved it with all this. Okay. I think we're almost done with this video, so let's go ahead and see what else I got. I believe I just have one more item. So I'm going to scroll back up and over and give you a definition. I think that's it. Yeah, that's it. So this one is something called a tautology. Okay. A tautology is a statement that is always true. In other words, all the answers are going to, all of that column that I circle are going to be true. And we actually saw that in one of the examples, assuming I did it correctly. Okay. Like I said, if you find a mistake, let me know. So that one would have been a tautology. In opposition, a self-contradiction is a statement that is always false. Okay, so we're going to go ahead and see if this one right here, this example right here, is in fact a tautology. So we're going to start with our truth table. We're going to do one more. Remember, this is the last one, so hang in there. So P, Q, we do all our lines. Okay, so there's 1, 2, 3, and 4. Okay, and we're going to fill in the values. So remember, we have they can both be true, one can be false, the other one can be false, and they can both be false. All right, let's see what we need for this one. So it looks like we need not P. So I'm going to go and put not P right here. And not P relies on this one. So that would be the opposite of those would be, let's see, false, false, true, and true. Okay. We already have P, so we're going to have to do this whole thing now. So I'm going to have to do not P or Q. So let's do that next. So not P or Q. And it looks like that one is an or statement, which means that as long as one of them is true, then it's true. So not P, I'm going to be looking here, and I'm going to be looking right here. Okay, so let's see. We have a true. We don't have a true here, so that's false. We have a true here, and we have a true here. Okay, so we're almost done. We're going to look at the final thing now. So now I'm looking at the entire thing. So that would be P or all of this, not P or Q. Okay, remember again that or, as long as one of them is true, then it's true. So now I'm looking at this column and I'm looking at this column again, the first one. So the first one, we have a true. The second one, we have another true because of this one. Third one, we have a true. And the fourth one, we have true. So if you look at our truth values, they are all true, which means that this is a tautology, and we just proved it. Okay? And that is it, guys. That is it. So pretty much this lesson is your introduction to these truth tables, which we're going to see a lot of in this unit. Okay, let me know if you got any if you have any questions.